Okay, what is a normal approach to landing? Obviously, what goes up must come down. And a normal approach to landing is a controlled descent. It's a controlled it's a controlled crash back to Earth, right? Every landing is a crash back to Earth, and we are going to control uh, all of the forces acting on an airplane all the way down to the ground. So we're going to fly the plane all the way to the runway. And what happens is when we land, we cut all of the lift at the moment that we touch down. That's the goal. And you want to do that very precisely as to make the landing as smooth as possible. So when we are assessing a landing, we have energy states. We have kinetic energy, which is our speed, and we have our potential energy, which is our altitude. And we're constantly assessing whether we're high energy or whether we're low energy. For the downwind portion, we're going to start at 1,000 feet. We know that that's 1,700 at Monroe because the airport elevation is 700 feet. So if we did a 1 nautical mile downwind to a 1 nautical mile base to a 1 nautical mile final, that's 3,000 feet. So, or that's 3 miles, and we have 1,000 feet, excuse me. And we basically want to cut that into thirds. So we need to descent 333 feet per nautical mile over the 3 miles to kill the 1,000 feet. And if we're on airspeed, we can check the 172 checklist here. They're showing the approach as 75 knots or 86 miles per hour, and short final is 60 knots. So that will be your approach speed. So if we're on speed, on altitude, then we're on energy. If we're high and fast, we have excess energy. If we're low and slow, we need to add energy. And there's ways of killing energy or adding energy. So if we're low and slow, there's a couple of ways we can do that. We can burn dinosaurs, we can give it more gas, and we can start to get more thrust. We can raise the nose up to climb and get our altitude back, or at least decrease the descent rate, increase the descent rate, climb, right, or descend less. So we can do that. Um, and right here with step 3. So our pilot controls the descent through management of power, pitch, and drag. The power will control our descent rate. So more power equals a shallower descent. Less power will be a steeper descent. And our pitch, raising the nose, will slow us down. Lowering the nose will speed us up. And then we can use flaps to modify the descent steepness. So we can come in a little shallower because we can fly at a slower speed with more drag without having to go high speed, it says here. And so that also talks about being behind the power curve. This is talking about the lift over drag formula that we talked about yesterday. But the lift over drag equation is balanced at best glide. And the best glide is 59 knots at 2,000 pounds, and full gross is 65. So somewhere between 59 and 65 is our best glide. We can get as slow with flaps all the way down to 33 knots, but we don't want to be there. We want to be at our approach speed of 75 to 60. And we said that stopping landing or instructing is hard. You get tongue-tied. When you cut the energy, when you stop the lift over the wings, you're settling the plane onto the ground, and that is essentially you stalling the airplane onto the runway, and that is continuing, or that is man, good thing I'm doing these and posting these on YouTube. That's great. Okay. That is what a landing is. So landing is cutting the stall or stalling the plane onto the runway, reducing all of the lift so that it is zero at the moment that you touch down. How your descent rate, how fast you are coming into for a landing can depend, right, based on your VSI. So if you're too high, reduce the power, extend the flaps. All right, if you're too high, we have too much energy. So let's cut the energy. So we can either cut the energy by reducing power, or we can add in some drag. That'll reduce the energy. If you're too low, we can add power. We can burn dinosaurs, or we can reduce the descent rate. So we'll bring the nose up. So that means we're low in energy and we need to get back on profile. And profile is the glide path. Now an ideal glide path is a 3-degree wire. That is shown here with glide path saying typically it's 3 degree for a normal approach. That's about what feels comfortable so that you're not coming in too steep and you have to swap a lot of physics close to the ground so that you have to cut it and then land. And that's not too shallow that you're buzzing the trees as you're approaching the runway. Aim point is going to be where you are visually guiding the airplane, and it's going to be before the tended landing spot. And then your touchdown point will be as you round out and you continue your flare, your touchdown point will be further away from your aim point. So this is a good picture here. It's showing your aim point is cut halfway between the runway threshold and the 1,000-foot markers. And so that would have no movement, right? That would just get larger in the windscreen and it would not move up or down the windscreen. You would just pin it right there. So that's how you know that you are aiming for it. If that aim point starts to shift up in your windscreen, that you know that you are ducking underneath it, that you're shallow, you have too low of energy. Now if that point starts to shift lower into your windscreen, then you have excess energy. You're aiming further than that aim point. So then you need to either pull power or slip the aircraft, add drag, or add flaps to slow down the aircraft. Having too much energy is a good thing if you know how to kill it. Having excessive energy is not a great thing. Then you'd want to go around, and too low of energy state close to the ground, again, don't delay the decision to go around. So here's the insight. If that point moves up the windscreen, you're low. If it moves down, you are high. I know it's a little difficult to mentally visualize, but we'll go over it here in Flight Sim. Okay. Common errors: unstable, improper airspeed, excessive descent rate, not holding crosswind, improper flare technique, failure to go around. Okay. You want to be stable, plus 10 knots. You want to have excess energy, -5. Touchdown, -0. You don't want to touch down short. You'd be touching down the grass if you go short. Longer is fine, knowing that we have plenty of runway ahead of us. And then we want to apply that proper crosswind technique all the way to the ground, and then even on the ground, we want to keep that technique in, that crosswind component, so we can keep that aileron, so we can have the weight on the wheels and weight on the ground instead of wanting to have some type of gusty wind come over and kind of try to get us to back to flying. No, we want to stay on the ground. All right, so here is the energy states. So let me pull up the iPad here and let's just talk through this. So we know that you can see here final is 1 nautical mile, base is about 1 nautical mile, and downwind is about 1 nautical mile. 1 nautical mile is about 6,000 feet. And we know that that perch point, or that area where we're going to be abeam the numbers, abeam the touchdown point, we're going to be at 1,000 foot. We're going to be at 1,700 on the clock. 1,700 is 1,000 feet AGL, above ground level. 1,700 is the mean sea level altitude, and we know that the airport elevation is 700 feet. So that's why it'll be 1,700. That's what the pattern altitude is. So let's talk about energy states real quickly. So if we know that we have a 3-degree wire, and we know this is 1,000 feet, and we know this is 3 nautical miles, then we have these areas that we can essentially have energy checkpoints. So this would be 667 feet, this would be 333 feet, and 333 feet over 1 nautical mile is it's a it's a 3-degree wire. You know, it would be 300 feet, but this is to the end of the runway instead of the 1,000-foot marker. So that's a good altitude to be at. And we wanted to be on, what was the approach speed? We want to be above 75 knots or right at 75 knots. If we are 333 feet, 80 knots, we're on energy. We're good. If we're 667 at 80 knots, we're good. Now, how do we know what 667 is? Well, we know this is 700, so we know this is going to be, what, 1367 here? And this is going to be essentially 1,000. So these are our checkpoints here. We want to be able to look for 1,000. Go away, Siri. We want to check here. We want to check here. All right, so let's go check them. All right, what's our energy state? Let's go ahead and look at it here. So where are we in time and space? Showing us at, you know, just to the east of the airport. Let's see if that's what it looks like outside. That's what it looks like outside. Going back to the map here, we look like we're over this gray patch of field. So these are visual maneuvers. So we're going to be looking outside. We know we're going to parallel Highway 74 here. We know the quarry is at our, 10 o'clock position, 10 o'clock low. And we're going to be flying just to the east of it when we come in on runway 23 here. Okay. So we're at 1710 on the altimeter. Our VSI is pegged at, looks like maybe -10, but pretty close to 0. And our speed is 88 knots. Okay, so we're on energy here. We're going to continue for about a mile. We're going to check our altitude. What does it need to be? It needs to be 1367 and 1033, you know. And these are, you know, the good pilot answer. Look your thumb, put it to the wind, get close enough. But the math there is to basically check our energy states. All right, let's go ahead and fly this. Okay, so we're trimmed off. We're going to start to cut the power. We're a beam. We're at 2100 RPMs. Power's coming back to about 18. And again, power is our descent rate, pitch for speed. So we'll pitch nose down, start to gain a little speed, bring the power back. We want to just look for our energy states, right? We wanted to be above 1367, so about 1400 when we got to the highway. We'll do a little check. There's the highway right there. And we're 1440, 1430. Okay, we got 100 feet high. Maybe 50 feet. And we're a little fast. So let's bring the power back. Let's keep our turn coming. We'll parallel that highway. We're actually going to be north of it, so we're going to be a little long. So we'll have a longer base leg. Airspeed's coming up, right? So let's go ahead and pitch. And we wanted to be 1033. Let's look outside. These are visual maneuvers to make sure we're lining up. And what's our energy state? There's 1100. There's 1060. So that's where we want to be. So we're 80 knots, 1060. Maybe we're a little low. Let's put a little more gas in. Let's put a little more dinosaurs in. We're at 1550 RPMs. All right, we're keeping that turn coming. We're going to line up with the runway here. We overshot, like always, Jonathan. And then we're going to get into our aim point airspeed, right? So 80 knots. We're going to slow it down. We're red. 4 pappies, 4 Vazzies. We're red. So we're going to get on profile. We're going to pitch up. We're going to freeze the descent rate. We're going to freeze the descent rate. Climbing back up. Cool. Now we're back. All right, we're going to freeze that spot in the windscreen. Watch it try to just stay just a little bit above the horizon there, a little bit above the deck. And then crack, shift, idle, and then hold it off. Hold it off like reins of the horse until we touch down. There's 60 knots. We said that's what we wanted to touch down at. 59 is what we touched down. Get on our rudder, maintain that center line, and bring it to a logical conclusion. We actually kept flaps up the entire time there. We could have used our flaps to slow us down a little bit more and touch down at a slower speed, but we decided to keep the flaps all the way up. So that's the approach to landing. And we mapped our brakes, so we actually have brakes now. And let's just shut it down. We'll bring it to a complete after landing checks. Flaps are up. Landing light. Landing taxi lights are off. And strobes are off. Elevator trim is reset to takeoff. Transponder standby. Sweet. Parking brake set. Avionics off, 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 off. Mixture. Idle cutoff. Mags off. I did that out of order, as you can see here. I did all of this out of order. Don't be like me. Have good checklist discipline.